Everyone, welcome to this lecture. In this lecture, I'll be covering the topic physical properties of alkanes. In the last lecture, I have completed all the preparation of alkanes wherein we have studied different reactions related to the preparation of alkanes. So kindly go through all the previous lectures before watching this lecture. Now let us start ahead with the topic physical properties. Now, before proceeding with physical properties of alkane, let us try to first understand the concept of alkanes in detail. Now, alkanes, we know that it contains only carbon-carbon and carbon-hydrogen sigma bond. Okay, alkanes contain carbon-carbon and carbon-hydrogen sigma bond, right? Then we know that alkanes, they are what? They are non-polar in nature. Now, why they are non-polar in nature, students? Now, if I write down any alkane, this is carbon, hydrogen, hydrogen, hydrogen. Okay. So basically, you take any alkane, there is presence of hydrogen and carbon, right? And then there is what? There is a very small difference of electronegativity between carbon and hydrogen. And because of that, this particular compound, it becomes what? It becomes a non-polar because there is not much difference in electronegativity of carbon and hydrogen, right? So the charges, it will be what? It will be almost same. Okay, it is not that one is having extremely high negative charge and the other one is having positive charge. Okay, so if that is the case, then the compound becomes a polar. But over here, the electronegativity difference, it is what? It is almost the same. Clear? Now, since they are non-polar in nature, they possess, okay, they possess weak van der Waals force. Okay, they possess weak van der Waals force. Clear? As the intermolecular forces. So there is the presence of weak van der Waals force, that is nothing but the intermolecular forces. The intermolecular force is weak. Okay. Now, because of this weak van der Waals force or weak intermolecular forces, the particles are what? They are held together weakly. And because of that, the first four members that is from C1 to C4 are gases. Okay. And then C5 to C17, these are liquid in state. And then coming to the higher members, are waxy solids. Okay. So over here, from methane to butane are gases. Okay, they are gaseous in phase. Pentane to C17, they are liquid. And the higher members, they are what? Waxy solid because of the weak van der Waals force. Clear? So this was related to the physical state. So the same thing you can apply for all the other chapters, right? So the lower members are what? They are always gaseous. Okay, the middle one are liquid and the higher members, they are what? They are waxy solids. Now the same thing I have mentioned in the notes. Quickly you can note it down or you can take a screenshot of it. So this is entirely revolving around what? It is entirely revolving around the weak van der Waals force, right? Now proceeding ahead with the next property, that is physical. Now proceeding ahead with the next property, that is boiling point. Now alkanes, as we have just discussed now, alkanes are non-polar molecules, right? So the molecules of the alkane, since they are non-polar, they are bound together by weak van der Waals forces. And that is the reason why they have a low boiling point, right? If the force is what? If the intermolecular force is weak, then definitely less amount of energy will be required to break the bond. Or in the other words, I can say that the boiling point of alkanes compared to the other compound, it is what? It is less because of its non-polar character. Clear? Now, if I go on increasing the number of carbon atoms, suppose if I have more than one carbon atom, for example, if I take methane, then coming to ethane, then coming to propane. So what will happen on the boiling point? Okay, now what the boiling point will go on, whether it is going to increase or whether it is going to decrease. Now quickly we are going to have a look on. Now pay attention. Always remember the boiling point of alkenes, they increase regularly with the increase in the number of carbon atoms. So basically boiling point, it is directly proportional to number of carbon atoms. Okay. This is the number of carbon atoms. Remember the chain, it should be straight chain. We are just talking about only the straight chain. After this, we are going to discuss about the branch chain. But for straight chain, boiling point, it is directly proportional to the number of carbon atoms. I mean to say, more the number of carbon atoms, more will be the boiling point. Now, why is it so? Now, why? What is the reason behind that? Okay. Now, quickly, we are going to have a look. Now, if I look into the number of carbon atoms, definitely the molecular mass increases if the number of carbon atoms increases, right? So, molecular mass increases, and if the molecular mass is increasing, that means I can say that the molecular size is also increasing, isn't it? And if the molecular size is increasing, students, definitely what is going to happen? The van der Waals force, okay, the van der Waals force or the magnitude of van der Waals force, it is going to increase. Okay, the magnitude of van der Waals force will also increase, and we know that everything is what? Everything, it is dependent on the van der Waals forces. Okay, whatever properties we have studied, everything, it is what? Dependent upon the intermolecular force between the molecules. Rather, I can say the van der Waals force. Clear? So in this case, because of more number of carbon atoms, the van der Waals force increases. And definitely, if the force is increasing, then the boiling point will also increase. Okay, the boiling point increases. Clear? So this is the entire thing related to boiling point if the chain is a straight chain. Okay, if the chain is what? It is a straight chain. And then it has been seen that the boiling point increases by about 20 to 30 degrees Celsius for each addition of a CH2 group. That means every time if one carbon atom is increasing, so basically we are increasing one CH2 group. And for every CH2 group added, there will be increase in the boiling point by 20 to 30 degrees Celsius. Clear? Okay. Now let us have a look on the isomeric alkane. Okay. Now isomeric alkane means the branched chain alkanes. So for branch chain alkanes, the concept of boiling point, it totally changes. Okay. Now quickly we are going to have a look on the isomeric alkanes. Now for isomeric alkanes, we know that there are different structures to write down the isomeric alkanes. Let us have a look on few example. So if I take the example of a pentane, so here the structure of pentane, this is CH2, CH2 and CH3. Then comes CH3, CH, CH2, CH3 and then CH3. This is isopentane. And then the lastly it is CH3, C, CH3, we have CH3 and CH3. Okay. So the first one is N-pentane. The second structure is iso. pentane. Remember, everything related to iso, N, neo, tert, and sec, all these prefixes I have explained in the earlier part of the chapter as well as in the previous chapter. So kindly go through all the previous videos to understand the concept in a better way. And the last one is neopentane. Now, if I look into the all the three structures, remember the branched chain isomer, it is having a low boiling point. Okay, the branched chain, more the branching, lesser will be the boiling point as compared to the straight chain. I mean to say, the straight chain will be having maximum boiling point. Then comes the branched, and the one which is highly branched, it is having the least boiling point. Now, why is it so? Quickly, we are going to note down the points, okay, the reason for this. Now, this is due to the fact that branching of the chain makes the molecule more compact. If I look into Neo compared to the first one, okay, over here in the first case, this is having more surface area. Okay, the first structure is having more surface area. Okay, whereas the last structure is having less surface area. Rather, I can say it is what? It is more compact. Okay, it is more compact. And because of this, the compactness, what is going to happen? The magnitude of the interparticle forces, okay, it is going to what? It is going to become less. Okay, that means the van der Waals force, which depends upon the surface area, that is going to become less. Okay, that is going to become weaker because van der Waals force, it totally depends upon the branching. Okay, if it is a straight chain, then the van der Waals force is greater. Okay, if it is the branch chain, the van der Waals force becomes less. Why? Because van der Waals force, it is dependent upon the surface area. Clear? So the branched chain has less van der Waals force, and whichever is having less van der Waals force, definitely that will be having what? That will be having less boiling point. Clear? So boiling point is inversely proportional to branched chain. I can write down the boiling point is what? It is inversely proportional to branched chain. Clear? So this is the entire concept related to branching and N-alkane. So quickly we are going to summarize. Now boiling point, two definitions or two formulas we have studied. Boiling point, it is directly proportional to the number of carbon atoms, or I can say it is directly proportional to molecular mass or molecular size. Clear? And then the second formula we have studied, students, it is the boiling point. It is inversely proportional to branch chain. More the branching, lesser will be the boiling point. Clear? So in this case, N-pentane has the maximum boiling point. Clear? Now, if I look into the same example I have written here, okay, you can just quickly copy down. Now, if I look into pentane and butane, so we need to compare between pentane and butane. These two structures, if I need to compare, definitely pentane, which is having more number of carbon than butane, the first one will be having what? More boiling point. Okay, this will be having maximum boiling point. Now, if I need to compare between these three, just now I have explained you, more the branching, lesser will be the boiling point. Clear? And between these two, the first one is N-butane, and then the second one is isobutane. Okay? So, between these two, N-butane will be having more boiling point because it is a straight chain. And then the second one, it is branched, so it is having less boiling point. Okay? I hope everything related to boiling point of alkane is clear. At the end of the video, we are going to solve more and more examples. Okay, so keep watching all the videos till the end, as well as in the next lecture, I will be covering few more examples based on the same topic. Okay, now let us proceed ahead with the melting point. Now, when I talk about the melting point, now melting point of N-alkanes, they do not show a regular variation. Okay, there is no such a smooth variation or regular variation in case of melting point. However, they increase in the with the increase in the molecular mass. Okay. Now let us have a look on the melting point. The melting point of N-alkanes, they do not show a regular variation with the increase in molecular mass. Okay, there is no such smooth or regular variation seen for the melting point, okay, in alkanes. But if I look into two types of alkane, okay, there are two types of alkane we can study, odd number and even number. Odd number means the compound which is having odd number of carbon atom, and even is nothing but the compound or the alkane which is having even number of carbon atom. For example, carbon atom 3, then 5. These are what? 3 means propane, okay? And then 5 is nothing but pentane, right? So propane, pentane, then we have heptane, right? So all are containing odd number of carbon atoms, and butane is containing 4, ethane is containing 2, then hexane is containing 6, right? So these all are even number of carbon atoms, right? Now, out of these two, remember the melting point of even number of carbon atom, it will be more than the melting point of odd. Okay, the melting point of even number of carbon atoms having the more number of carbon atoms, or the even number of carbon atoms, it is having less melting point. So remember, the alkanes which are having even number of carbon atoms have higher melting point than the alkanes which are having odd number of carbon atoms. Okay. Now, why is it so? Now, what is the reason behind this? So, quickly we will look into the reason. Now, quickly we are going to look into the melting point concept in detail along with few examples. Now, as I said, the melting point of odd carbon atoms will be having less melting point than the even. Now, this is because the intermolecular forces in the crystal, it totally depends upon the size. Along with the size, it also depends upon the crystal lattice. Okay. Now, if a molecule, it fits into the crystal lattice perfectly, then the melting point of that particular molecule, it will be high. Okay. So, I'll write down here quickly. It depends upon the size of the molecule. Also, it depends upon the molecule, how properly it can fit into crystal lattice. Okay. Now, the molecule which fits into crystal lattice, it is what more easily due to their symmetric structures. Usually, they are having what? They are having. Now, the molecule which can fit into the crystal lattice, that means this is I'm just taking the example, okay. Suppose a molecule, it is perfectly fitted into this crystal lattice, right? So, it requires lot of energy to break this lattice, isn't it? It requires a high amount of lattice energy to break this lattice. And because of that, this high energy, the melting point is what? The melting point is high because it requires a high amount of energy to melt it. Clear? Let us take one example. Now, if I talk about N-pentane, CH3, CH2, CH2, CH2 and CH3. Okay, and on the other hand, the same example we have taken like the boiling point. Okay, the previously we have taken the same example. This is CH3 and then we have CH3, CH3, CH3 and CH3. So over here I have N-pentane. This is isopentane And then the last one is neopentane. Okay. Now, if I look into all the three structures, I can see that the melting point of neo structure, this is the maximum. Okay, the melting point of neopentane is maximum. Now, why is it so? Among all these isomers, if I look into all the three isomers, the neopentane, it has highest melting point. Now, why does it has a highest melting point? Because the structure is what it, the structure is spherical. Okay, the structure is what it is almost spherical. I can say that it is closely packed. Okay, if I look into the structure, this is a carbon atom, and around this carbon atom, there are four carbon atoms which are compactly packed. Okay, it is symmetrical from all the four sides. Four methyl group are present. So over here, this is spherical, and because of that, it can be closely fitted into the crystal lattice. And if it can closely fit into the crystal lattice, then definitely high amount of energy will be required to melt it. Clear? So this is the entire concept related to melting point. Now, if I look into odd and even concept, odd and even, okay, now, if I look into the odd and even, we know that the alkanes, they form zigzag structure, right? They have a zigzag type of chain rather than the straight chain. Now, in N-alkanes containing even number of carbon atom, if I write down the structure of N-hexane, okay? Now, this is the structure of N-hexane. 1, 2, 3, 4, 5, and 6. So total how many carbon are there? 1, 2, 3, 4, 5, and 6. Clear? So if I look into the structure of N-hexane, over here I can see that there is a carbon. And then on the other hand, I have N-heptane. Okay, let us take N-heptane. This is 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, and 7. Okay. Now in this case, I can see that the first structure, it contains an even number of carbon, and the second structure, it contains an odd number of carbon. Clear? Now, in the odd number of carbon atoms, the terminal methyl group, if I look into the terminal methyl group, I'm talking about this one. Okay, this is nothing but one carbon, and this is also one carbon. So basically, terminals, there is a presence of methyl group. This is CH3, this is CH3. So in the odd number of carbon atoms, the terminal methyl groups, they lie on the same side of the chain. Okay, the terminal methyl groups, they are lying on the same side of the chain. Whereas in the alkanes, which are containing the even number of carbon atoms, I can see that there is what? There is the methyl group present on the opposite side, right? So if it is present on the same side, then what is exactly happening? Okay, what is exactly happening? So I can see that the methyl group, so I can see that the methyl group, they lie on the same side, okay, of the plane. So in the odd number of carbon atom, I can see that the methyl group, it lies on the same side of the chain, right? It appears that the alkanes, which are having odd number of carbon atoms, they are relatively more unsymmetrical. Okay, they are relatively what? They are unsymmetrical, and then they do not fit in to the crystal lattice. And if they do not fit closely or compactly in the crystal lattice, definitely what is going to happen? The alkenes which are having the odd number of carbon atoms, they will be having less melting point. Okay, because they do not fit into the crystal lattice perfectly. Whereas if I talk about the even number of carbon atoms, I can see that there is methyl group present on the opposite side of the chain. Okay, this is CH3. Over here we have CH3. So that means the methyl group, they are present on the opposite side. And if they are present on the opposite side, then definitely they can be fitted. Okay, this is symmetrical then. Okay, this is symmetrical and they can be fitted into the crystal lattice perfectly. Okay. And if it can fit into the crystal lattice, definitely high amount of energy will be required to break the bond, or the lattice enthalpy energy, it will be high. And because of that, the melting point in case of even number of carbon atom, it is high. Clear? So I hope the entire concept is clear to you. Always remember the melting point is what? The melting point of the even number of the alkane, it is higher to the melting point of the odd number of alkane. So quickly we will summarize whatever we have covered till now. So we have covered melting point. In melting point, we studied the entire topic. It is revolving around the van der Waals force, or the entire topic. It is so quickly we are going to now revise. We can see that the melting point topic, it is entirely revolving around the crystal lattice. If a particular structure, it has a tendency to fit into the crystal lattice properly, then that is called as what? It is having more melting point. And out of odd and even carbon atoms, they are having more tendency to fit into the crystal lattice perfectly. Okay, because of its structure. Now, if I look into neopentane or heptane, hexane, okay, the entire topic I have covered. And in the next lecture, I will be discussing about few more properties of alkanes. And along with the properties, we will be solving few questions as well.